Hello, everyone. Welcome. We were talking about this particular pattern in the previous lecture, the bridge. Hopefully now, something that I will suggest is if you can listen the name, read the name like bridge, and you can draw in your mind the class diagram. If you can remember the class diagram, and you can associate the name, the concept with the class diagram, that gives you a very good idea of what problem are you solving. For instance, for the bridge, the idea of a bridge, what we're connecting, and according with what we reviewed previous lecture, is like what we are connecting is two families. It doesn't matter if you remember the details of the content of these classes or how many childs each class has. The key idea is you are connecting these two families of classes. Now, better, if you can remember the connection, the particular connection was very, very special here. Involve a diamond, if you remember. I just draw the lines. But if you can remember that what you have is a diamond involved here, moreover, if you can remember that what you are connecting are the top of the families, and usually that guy, the root of these trees, is an interface, and therefore this arrow, this arrow, this arrow, this arrow is not going to be a solid line, but a dashed line, realization instead of inheritance. You have the idea. We review that thing, and well, the two big ones. Remember, for the Goff patterns for the book, some questions that some people ask, usually after the exam, is like, these arrows here are solid. Yeah, those are solid because in the book, the description is connection between abstract classes, not interfaces. Why? Because the diagram is 97. The picture is the definition of inheritance between an abstract class and the concrete classes in 97. Something that today, in Java in particular, we make these guys interfaces. And therefore, just because these are going to be interfaces, the connection become realization, not inheritance. So just consider that. Always is good to know the original picture. I show you always the picture, the original one, and then we move to Java or concrete problems. But it's good for you to be aware of, okay, this is the Goff picture for a particular pattern, in this case for the bridge. So connecting to families. Why? Source code. I do not need to tell you how to create the interface. I do not need to tell you how to do the classes that inherit from the interface. The only thing is, when you have these two families, this bridge, what you want to achieve is something like this. And hopefully at this moment, you can connect this source code with a structure of classes similar to this one. What is happening? What is happening is, number one, I am creating an object from one of the families. Number two, I am going to connect this guy. Remember this diamond? And remember that that diamond basically is this guy have inside a variable from a different class, from the class that I am going to connect. And you remember that always when you have this diamond, there should be not only the variable, but an add or a setter in order to provide a value for that variable. Hopefully that now is kind of, yeah, it's common. It's going to be there. The only thing that I am going to do is to use that method. In this case, it's a setter, following the original template. It could be an add if you want. The original object, the origin of the bridge, one method setter or adding, and the parameter is going to be a parent, an object from the parent class in the other tree. And what I am showing you is I am going to connect this one with this one. But if you have childs connected with these classes, inheritance, remember, this is going to be polymorphic. Any of these parents can be there replacing the childs, or you can use any child in the position of these two parents. You can change this one or this one with any of the classes in the families. The connection is at the top. It works with the full family. Well, remember, the diamond is white because this variable can be null. There is nothing that avoid me to do something like A, B, Z, blah, 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 and just pass as a parameter a null. There is no verification of the argument being something different than null. And remember, always, 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 if there is the possibility for the variable to be null, the diamond is going to be white. Good. In fact, the idea is that I can have a bridge that is null, so a bridge that does not exist. That's it. Good. So pretty simple. Next. Another pattern. You're going to notice similarities between the patterns. When we start and we review the observer and the decorator, two different diagrams, complete different relationships, structures, and so on. In the previous lecture, we reviewed something that is like, oh, this is something that I already reviewed before. This is very similar to another. And it's going to happen the same today. Strategy. Well, here, if you make the validation in order to this one to do not be null, you can change the diamond to black. It's going to be a modified version of the pattern, not the original one. But remember, the patterns are templates. You can customize your patterns according with the problem that you have. And if you want to create a bridge, and just to be sure that the bridge always exists, yeah, you can validate that that guy is always different from null, and therefore in the diagram, in order to show that you are doing that such validation, you can change the diamond to black. However, it's not composite yet. I mean, it's not composite the pattern because that one have different elements. It still will be considered a bridge, yes. I mean, again, the original one, the pattern, the template is white. If you modify things, for instance, validation of the null, it's still going to be a bridge. Now, a different flavor of bridge. If you remember observer, for instance, remember that the diagram in the original pattern and the diagram of the observer using the classes in Java, a little bit different. Some small differences. The original one have two inheritance. The one with Java, one is inheritance, the other is realization, among other things. They are still observers, a different flavor of observers. Notice that if I am changing inheritance to realization, or if you change the diamond black to white or the opposite, those are small changes. It's still the same pattern in a different flavor. If you add new relationships, like if we start adding here things crazy like this, I don't know, whatever, that is a different thing. That is a different pattern. That is something completely different when we saw two more diamonds, three more relationships. So just be careful with that. Small modification, a different flavor of the template, big radical changes. Probably you are doing something else that is not the pattern, which could be good or not, depending on the problem that you are solving, but just be careful with that. Good. Okay, so bridge, a different one. What happens if I have a problem, a software, And in order to process some data or in order to do something, there are different ways to process that data. There are different ways to process that something. And instead of having a long list of if-else to validate what to do, or instead of having kind of a hard-coded solution, I would like to define in real time which algorithm is going to be applied. Just think about it. Real time, I have some data coming in. Real time, as a user, I would like to select, okay, you know what? Do this with the data. This is a particular algorithm to process the data, or do that or that. I would like to change the process in real time. You can start thinking, I can do several different things in order to do that. I can use if-else conditions. That could be the first idea, just because that is one of the first things that you learn. And if-else. The problem with the if-else is that the condition is there in compilation time. You cannot change the condition in runtime. Well, I can use variables in the condition, so what I can do is change the values of the variables. There is always a solution. There is a different approach. Again, it's not that the if-else are bad. It's just like there is a different approach that maybe could be better in terms of split the work between the team. That solution, strategy. The problem that the strategy solves is I want to have a family of algorithms, and in real time, I want to select one of those. A family of algorithms and select one member of the family to be applied, and that in real time. This is the template. This is the class diagram. Looks familiar to something? It's like some diagram that we reviewed before, or not, or is totally new. Strategy. Bridge. Remember, this is a comment. So you told me that a bridge is this connection between two families. A strategy is a connection, but I do not want to connect two families. In fact, really, what I have is one family. What I am concerned is about one family and something else. The something else could be another family, just like with the bridge. The something else could be one class alone. The pattern is telling you, I don't care what is one of the sizes of the bridge. I don't care what is this. But the second one is going to be a family. But not any family. It's going to be a family. Algorithms. Okay. You want to connect two things and you don't care about what those two things are, use a bridge. Bye. Okay, wait. You have a particular case in which one of the ends of the bridge is a family of algorithms and the other one is someone or something, we don't care what, that you want to cross the bridge in order to take one algorithm, even in runtime. Your keyword, instead of being bridge, Now your keyword is strategy. The name of this template is a strategy. When you talk about, I am going to use a strategy, what you are telling is, I am going to have a family of algorithms, and that family is going to be connected in real time with another part of the problem, your software. When you're telling, I am going to use a bridge, it's like, I have two families, could be whatever. I do not know what they are doing, but they are two families. They are handling data or they are handling processes. We don't care. I am going to connect. If you want to think about the level of abstraction, the bridge is generic. The strategy is specific. It's a particular type of bridge. The strategy is like the bridge, yes, but a bridge with algorithms and something else. This connection. With the bridge, you have two families. We define that a family could have only one member. The idea is there are two families, but you remember, if we are talking strictly about numbers, you can have a family with only one member. You like the context. The key part is two families, we don't care what those families do. Here, two families, specifically one, is a family of algorithms, more than one. That is the reason because these three childs. The second part is a family. In particular, they implement different versions of one algorithm. Algorithm mean process, instructions, not only data. Something is happening there. They process data. They have instructions, and there is a family. So there are different versions of the same process for the data. And there is a family with more than one. It's not like I am going to create a bridge with a family that have only one algorithm. That is the key idea. Good. So again, bridge, strategy, the key idea, the algorithms. And if you think about the implementation, I am pretty sure that it's like, well, yeah, the idea in terms of the philosophical thing is pretty clear. What about the programming? As you can expect, the programming that looks like the context. And the bridge. Professor, in the previous one, you make the connection with a setter or an add. Here, you're doing the connection with the constructor. Used to show you the examples. Any difference about it? Any difference about using a constructor to pass a value or use a setter? And hopefully you agree with me. In terms of object-oriented, providing a value for the variable, you can do that in the constructor. You can do that with the setter. The only thing is provide a value. Do this guy, the variable that you create because of the diam. Obviously, the reason because we want to do this is because we want to use this object to call a particular method. Inside of that method, what is going to happen is we're going to call a method in the object that is in the other part of the bridge. It is the same here. It is the same in the previous one. You call a method in your side, that method inside that is the method that I have in my side. What that method is going to do is to call a particular method that is in the object that is the global variable in this class, and that is the data type from like this parent. The object strategy, a global variable strategy, and this method, the only thing that is going to do is put that object to work, calling some method in the other side. In particular, for the strategy, calling the method that have the algorithm implemented. So I am calling always the same method, but depending on the object that I pass as a parameter is the algorithm that I am going to be running. So I do not need an if-else to select what to do. What I need is real time to create one object and the other. Whatever method or whatever is in the method here that is the algorithm is the one that is going to be implemented, because I am going to connect this object with the other one. No need for the if-else. Just be careful with what is the object here. Is A, B, or C? But you're going to need an if-else in the listener in order to create one of these objects. That is a different story. In your view, the graphical user interface of your program or the text-based situation, that is something that maybe you need to do in any case. But here, for the problem, for deciding which algorithm to run, it's not about if-else. It's about what object do we create, any of the three options in blue. The relationship, I have a question about the relationship with Dash. Which one? Here? We are calling a method. So the only thing here is this line here is solid because of the diamond. We have the diamond represented, I have a global variable, and then we put the line because I have it, and I am going to connect with what I have, but automatically, if I have it, I can use it. So remember, always, 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 for using, you do not put the diamond. But when you put the diamond, the relationship of having include is understood that if you have something, you are going to use that something. So this one is solid because this variable here is global, the diamond, and you are calling a method using that global variable. So the diamond is going to have this arrow in solid. You are calling the method. If you ask about the line with dashes, this one basically represents that you are calling the constructor. If you remember factory, that is the line that we have between the factory and the product. And the reason is because the factory is not really calling a method in the product. The only thing that the factory is doing is calling the new. And therefore, because of the new, calling the constructor. However, the constructor is not really a method like I am using, triggering an action. However, it's a connection. This one in particular, the line with the dash, is use dependency, that is different from association. Association is using, but this dependency is I need the class because of the new, but I am not using it. Usually the dash is like a relationship that is a little bit more light. So it's like, if you have the line in solid, I need it because I am going to trigger some action there. If the line is not solid, it's I need it, but I do not really using it or triggering an action. It's just because my responsibility includes to create an object from that guy, that class. That's it. So kind of a connection that the coupling is a little bit lower. But so far, the only point in which we have used this one is with the factory and the products. Here, because I am calling a method, not the constructor only, I need the line solid. So, and the diamond. Good. Okay, so strategy, bridge. Hopefully, so far, so good. For your exam, and just to be sure, can you identify which one is strategy, which one is bridge, right? Number one, if you read the name of the classes, that one is going to speak to you. The other, there is no name of bridge in any place. There is no class or comment with the name. But hopefully you can check and identify important elements. Important thing, guys, I hope you are able to identify the different diagrams. Some of them are going to be very easy. Something is going to tell you, here I am in strategy. Others, like this one, not so evident. There is no bridge there, but one family, another family, one connection. Try to remember them. Could be useful. Good. So, question in your exam, what is the difference between a strategy and bridge? Can you summarize an open question in that open question, the answer in one line or two? Difference between a strategy and bridge, if any. Key idea. If you have 1 minute or 30 seconds to answer, what is the difference between a strategy and bridge? What will you write as an answer? I agree with the answer in the chat. Hopefully everyone else is reading and agree with that. I will say that is the idea. Oh, I have another answer. I like the idea. Two families. You remember, both are connection between two families. It's just like in one of them, the families can be just like two families, whatever. In the other, there is kind of an extra requirement about one of the families. What is or what one of those families represent. So general and specific. Just remember that part. Good. So far, easy, hopefully. The same thing that you told me in the chat, you can review this later for the exam. Another one. By the way, I forget to answer bridge and strategy. In which category are they? They are behavioral patterns, creational patterns, structural patterns. Okay, so remember that we review creational, the singleton, the factory, the builder, and then we move to the behavioral ones. We review the observer, and right now we are with the structurals, and the patterns that we have been reviewing, including these two, are in this structural, the category at the center. So good. Okay, so connections between patterns, structural patterns. So far, great. Next, another one, chain of responsibilities. A very good question. No. If you are using the diamond, and the diamond represents that you have an object, a global variable from a particular class, and later you are using that global variable to call methods, that is good enough. Question for your exam, the tricky question. Class A, class B. If I show you this, and I ask you for the source code, I am sure that you can imagine the solution. Two classes, a global variable, and we can use the global variable. Tell me. Can I have between two classes, A and B, both association and aggregation? And if so, what that mean? I told you, tricky question. Let me give you the source code, and you're going to notice what happened. Tricky, yes. What I am telling here is that I have a class A, and I have a class B, right? Moreover, the relationship with the diamond basically represents that I have a variable here from the class B. And it's a diamond, it's white, therefore there is a possibility for that one to be null. And that possibility could be used like, I have the variable, I do not put the new there, I am not going to put a constructor, so the possibility is that it's null, therefore the diamond is white. Then, in this class, I am going to have a method, the method M. We don't care about the name. But inside of that method, I can provide an initialization for B. Notice that the method is M, is not a constructor. So we do not have 100% insurance that the method is going to be executed. Therefore, we cannot put the diamond in black, because if that method is not called, that B is null. And again, if we do not have 100% certainty that the variable is going to have a value, the diamond is white. So in this scenario, the diamond is white, I do the initialization in M, and then I can use B, and for B, I call a method. Do it. Okay. So that means that we have a method here. Do it, whatever. If I give you this source code, can you agree with me that that source code, so far, the only thing that represents is this diamond and this relationship? That is what I have so far. Right? Everything that I have in source code is that relationship. Is the global variable B, the global variable B, the global variable B. If this is my source code, my class, my connection between A and B should be only the aggregation relationship. What if the aggregation still covers the relationship between A and B? And hopefully you agree with me, no. Now I have a new relationship. A new relationship, what? I have a local variable and I am using a method with my local variable. I have association. And that is the only reason in which I need both arrows. Two different relationships. I have global variable and I have local variables. I am not talking about the number. Remember, you can play with the numbers if you have several globals or several locals with the asterisk or a particular number. The point is, if you're using both relationships, aggregation and association, you need to represent both. But if you are using only aggregation, like the global variable, it is by default that you are going to use that variable to call methods. So you do not need both arrows used for B, but we have both arrows because one is B and the other is this X. Makes sense? Good. Question in your exam, and in that moment, we can play with crazy things. What if I told you that this is A, I have a B here, and I have an aggregation A and B, but I have association in the opposite direction. That is tricky. Yeah. Can you give me the source code for this diagram? Use as I provide the source code for the diagram above. And you're thinking, yes, we can. Great. It is clear what could change, right? You need to do something with the things that I put in the circle. Okay. For your exam, things like this help me to know, can you understand exactly what is happening with the arrows, the meaning of those arrows? So aggregation, association. Moving forward, chain of responsibility. Chain of responsibility is a pattern in which category? Yeah, and I agree with the answer in the chat. So if you're reading, yeah, exactly that is what you should do. Okay, chain of responsibilities. The name is very suggestive. It's like, imagine that I have an object and you can think like the professor. And someone asked me to do something. In terms of programming, if someone asks me to do something, probably that is about calling a method. So imagine your class professor and professor have a method review or appeal or something like that. And someone, some other class is going to ask for that. It's going to send a request. The chain of responsibilities is about the following. What happens if instead of having one object, one class attending requests, we create several classes and therefore several objects. And you know what? When professor receive a request for a review, the only thing that I am going to do is to send the request to another object. And that one have the possibility to reply to the request, or maybe that one is going to send the request to another object. And this can continue. And that is what we call the chain of responsibility. Now, just to be clear, part of the definition of this is the chain. We have the professor, we have the TA, probably we have a grader here. There is possible that when you send a request to the chain, it will happen that the first element in the chain reply. It will happen. The first element never asks to the others. It's like you send an appeal to the professor and the professor replied to you. The TA and the grader never know about it. But also it could happen that the professor, the first element in the chain, send the request to someone else. That someone else, according with the pattern, is going to reply not to the student directly, but as you can expect, to the professor, and the professor is going to reply to the one that sent the request. The pattern is all about a facade. You are sending a request to me, a student, to a professor, and for you, you do not know what is happening in the background. You do not know that there are more objects handling that request because you are interacting with the head of this chain. Moreover, maybe this TA didn't handle the request. The professor received the request, sent the request to another one, the TA, but this TA, instead of reply to me, maybe send the request to someone else, for instance, a grader. Again, the grader is the one that is going to process the request and is going to reply to the TA. And then the TA is going to reply to the professor, and the professor is the one that is going to reply to the student. This thing in the big green border is the chain of responsibilities, a common facade, and you can have a line, a chain of different objects helping you to process the request. But one and only one do the process. Is one of them, the grader, the TA, or the professor, one of them is going to solve the problem. The others are just going to pass the response to the class that make the request. This is the idea. Hopefully the idea is clear. If you notice, as several other patterns, the idea comes from things that happen between humans. We represent a human being in an object, in a class, and the good solutions for problems are the same good solutions that we apply when we're working in a team of human beings. The only thing that we're doing is teaching the objects to work in a similar way. Can you imagine how to implement this in terms of object-oriented programming? Moreover, can you imagine the class diagram that is going to help us to create something like this? And I am sure that you're going to find familiar this. This is the pattern for the chain of responsibilities. This is the class diagram to implement something like this. But before moving to the details of the coding, I am asking, look familiar? Have we seen something like this before? Decorator. And one more. It's just like decorator, and decorator was similar to another one that we reviewed in the previous lecture. Remember? Yes. Okay, you have the idea like, again, one parent, two childs, and one of the childs have the diamond. Like again, is the third pattern that we review with this structure. And obviously, because it's the third pattern that we review with this structure, you already know the source code. We spent 2 lectures reviewing the source code for the decorator. And if you remember, it's the same source code for the composite. One small difference. Do you remember the difference between the composite and the decorator, by the way? Because the diagram was very similar. Having kids, extra childs is not a difference. This is the core. Decorator. Decorator was this idea of one element, the ball, remember? that can be inside of a box, but just because the box have this diamond, can be inside of another box and another box and forever, remember? And then we move to the composite. And in the composite, the only difference that we saw was, well, now I can have more than one ball inside of a box. But moreover, I can have more than one box with more than one ball inside of another box. And I can have another box that is only one or maybe two, one line, multiple. In particular, the key idea here is these three, right? Remember? Composition, decoration. And I am sure that you are asking yourselves, it's like, well, again, the same draw? Again, the same idea? What is going to be the difference? This guy here is going to be the employee with the lowest rank. This guy here is going to be, like in my previous description, this guy, the last one in the line. Always the last one, the tail in the chain. That one is going to be this one. If you want to think about my previous example, this one is going to be like the grader in my previous example. This one here, all the others. All the others. You want the professor and the TA? You can create here a class, and you can create here a class, and you can have here the professor, and you can have here the TA, if you want the details. So the first one, the tail, and the others, the elements in the chain that are not the tail. You want one, or like in my example, more than one? Create childs. You know that you can do that. Yeah. And you know what we are going to do? We're going to create a chain. We're going to create a chain. We're going to have one guy that is the grader. And we're going to connect that guy with any of these two, with the others. And we're going to connect this one because of the diamond with another that could be any of those. And we can continue doing the connections. Wait, that is kind of the same than when you talk about this one as the ball and this one as the boxes. But you tell me that this one, the last one, is the ball. And you mentioned something like adding that ball inside of a box. So you have these two. And you told me that you can put that one inside of another box. So it's like you have these three. In one scenario, you are talking about having something inside something. In the other scenario, you are talking about just connecting. Is there any difference in terms of programming for having the ball inside of the box or for connecting the grader with the professor? It's exactly the same. The only thing that changed is the philosophical concept. Think about it. Uh, if I told you that I have a class A, and I told you that this class A have a variable B inside, if I create an object A, and I create an object B, B, and A, I can tell you that A is connected with B just because I could have here a method and somehow use B. I can create the draw like this, but also it could be okay if I told you I have an object A and that object A have inside an object B. The problem is the same. The only thing that changes is what I am representing. How do I am presenting the relationship? But if you think about it, we mentioned this one inside of the other because I have this variable inside. But if you think about your knowledge of programming, is really this variable inside of the other object? Is this example here real in terms of what happened in the computer? Yes or no? References, pointers, this is not true. The reality is they are connected, not inside. In fact, you can talk about connection or inside depending on your philosophical point of view. The source code is the same. Okay, so that is the reason because I can have the same class diagram, therefore I am going to have the same source code. But for one particular problem, I can represent in this way chain of responsibilities, and for a different problems, composition or decoration, I could present the problem, the explanation, the description with this idea of one thing inside of another, the visualization in that way. Yeah. Why? Now that we agree that is the same description, the same source code, now we can focus in what is the advantage of one and what is the advantage of the other. In which scenarios we use A or in which scenarios we use B. Can you remember for the decorator and for the composite, when we put in A or in B the other object, what we add? We add here and here attributes, data, or we add methods, actions. We add some extra functionality, yes. Variables. Do you remember the examples that we did with the decoration? You add only methods or maybe something else? As a general rule, with composite and decoration, you can add whatever you need. A decoration or a composition is about data and actions, whatever you want. Both work. If you did the example with the plot and I asked you to decorate, I am sure that you need some extra variables and you just add the variables in the new classes. More variables here, obviously methods. Variables, methods. If you're thinking about adding functionality, adding attributes, variables and methods. If you remember when we talk about inheritance versus decoration, composition is a replacement for inheritance. And inheritance allows you to inherit both variables and methods. There is no limitation about that, right? Told me, according with the explanation that I give you for the chain of responsibility, what we want to add is variables and methods or use actions. And I want you to visualize this again. Like we have composition. And you remember that composition is this idea of an object that can have inside another object, the boxes. A particular case of composition is this decoration, in which it's almost the same, but instead of being able to add whatever is, we're going to add one. Remember, one ball, one box. But in both cases, you can add variables or methods. We don't really care. But if you have only one, and the goal is to add actions, we change the name. The new name, the chain of responsibilities. And hopefully this helped a little bit to clarify where each of them is. Composition, adding any number of objects with actions and variables. Okay, only one with actions and variables. Okay, only one, but for actions. Chain of responsibilities. Good? Source code. Looks familiar? The first paragraph? It's like something that you can remember doing just because this part of the diagram. Yes or no? It is the same for decorator. It is the same for composite. We need to do the example, but decorator, composite, chain of responsibilities is the idea of creating the objects and connecting them. In particular, this should look like decorator, as you mentioned, just because we have this idea of H1 that is going to be connected with H2, that is going to be connected with H3. And if you want to think about the chain of responsibilities, it's going to look like that. But if you want to think about the description that we did before, H3 inside of H2, which is inside of H1. And both pictures are correct. The variables are inside of, but in programming, there is nothing inside of nothing. It uses references and connections, like connections. That is going to be similar, identical with the three patterns. Now, the part in which we notice the difference is what we want to do. And what we want to do is, as in my description before, I am going to have someone, another class, this class here, making requests, like the example that I showed you with the appeal or the review. And that other class, that other element in my program, is going to send a request, it's going to call a method. It's always about calling a method. It's going to call a method in the head of the chain. It's like it's going to call a method in the external element, in the first decoration. And that guy is going to receive an answer. What happened inside, as we described before, here, the request is going to go to this one, and that guy have two options, replay or pass, and this guy have two options, replay or ignore. Somehow, this is going to have an answer. Just like this. Source code. The only source code that we need is this one. The handlers. Remember the class diagram? Do you remember that we need a parent? A parent for the full family. As usual, the parent, we do not want that parent to create objects. The only thing that we want is that class or interface to be there to connect the family. In the change, every single element is going to be called a handler. The professor is a handler, the TA, the grader. Those elements that have the possibility to provide a reply to a request. In particular, one of the childs of the handler, one of them is going to be this one, implementing the diamond. The variable. I am talking about one of the guys with the diamond. Nothing new here. The variable, the add or set. Somehow I need to add a value to that variable. That is the method that I called before to provide a value there. And the method that I am going to be calling. And remember, that method is going to be in every single member of the family. All the elements in the chain are going to have that method. The childs, all of them are going to have the method. Class number one with the method. It is a child. Another child with the method. And the only thing that I do is, okay, one of the elements in the chain receive the request. I receive the request, and the two possibilities that I mentioned before is a condition. All the classes, all the childs have this if-else. All the elements, the professor, the grader, the TA, those are classes that are inheriting from a common parent. And inside, they have this request, process request, handle request, whatever, one method. And inside of the method, the professor, the grader, and the TA, they are going to take a decision according with one condition. They are going to pass the request to someone else or they are going to do something. I am the professor, I receive an appeal, the appeal is about a particular assignment. I do not grade the assignments, I am going to pass that request to the TA. I am the professor, I receive a request, a message, the message is about a particular topic that you are asking for more information. I will handle that request. Pass or handle, reply. The TA is going to receive the request for a review of a particular assignment. The TA is going to say, I didn't grade assignments either. I am going to pass that request to the grader. The TA receives a request about reviewing a grade in the exam. The TA is going to say, okay, I grade exams. I am going to review this and provide a replay. Always two options. That is what you have. You can be thinking, when is a good idea to implement a chain of responsibilities? What is the use of this particular pattern? Any idea? That is a modification of the chain of responsibilities. Yes, when you have multiple requests and you need to balance things, one thing that you can do in the chain of responsibilities, can I handle the request or I ask for the help of another process in a different server? That is a good implementation. However, it's an extension or modification of the same idea. Thinking about use one computer, use programming outside of this environment in which the resources are important, use when you are doing something in your desktop. The key idea of this pattern in 97 was to replace a collection of if-else. Remember that when you have if-else, 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 that increase, each condition increase the cyclomatic complexity of your source code. I do not know how familiar you are with the metrics of the software, but one of the most important metrics that you have when you are developing software is cyclomatic complexity. Cyclomatic complexity basically means the number of conditions that you have in a method plus one. The number of conditions doesn't matter if it's an if-else or a for loop or whatever, but how many conditions do you have plus one? And that number is called cyclomatic complexity. And you measure that per method. And you know what? The maximum cyclomatic complexity allowed or recommended in a method is 10. So the key idea is, every single method that you have in your software should have 9 or less conditions. 9 plus 1, 10. That is your kind of threshold. Sometimes you cannot achieve that if you're programming with if-else. So options to remove the if-else. Obviously, option number one, the novice programmer is, well, if I cannot have more than 10 conditions in one method, I can create 2 methods or 3 methods and put 10 conditions in each method and basically one method call the other. Yeah, it's a solution. You keep the number in 10, but it's not exactly a good solution. The good solution, one of them, chain of responsibility. The reason to use the chain of responsibility is I have a lot of conditions. I need to check a lot of factors in order to decide what to do. So instead of have all that conditions in one single method, in one single class, it's like this. I check one condition, do the thing, or send the request to someone else. That someone else, check one condition, do the thing, or send to someone else. And you can continue. The good thing here is you can have multiple developers working in the same group of conditions, but each developer is going to do the class that check one condition and the action associated with that condition. Just like I described with the TA, the professor, and the grader. My class is TA. What I need to do is to implement this method. In this method, the only thing that I'm going to do is to review that the request that I receive satisfy whatever are the conditions or the requirements for me to process that. If the requests have all that structure, I am going to do something. If not, the only responsibility that I have is to call the next in line. So I don't care about the request, it's not mine. Call the next one. That's it. Obviously, in some point, it could be used process with an answer, void, or the method can return something, and I can return something that I calculate, or I can use return whatever this guy returned to me. It's always a line. That is the reason for this pattern. That is the reason for this new option. Questions? Good. So, chain of responsibility, composite, decorator. I give you the 3 patterns again for your exam. Just be sure that you can identify them. The diagram is there just to give you hints, but the important thing is to remember what is the difference between composite and decorator, decorator and chain of responsibilities and composite. Any of those questions could be in your exam. Just remember to review and to have a clear idea of the difference. It could be an open question or it could be multiple choice. Even if it's multiple choice, you need to select one of the options. Remember the key ideas. Okay, guys, read the paper. See you next week. Do not forget your quiz. Good. Bye.